Today's lesson is called Distributive Property and Combining Like Terms, Day 1. So we want to start with the first main idea, which is what are the parts of an expression? So we'll start with variable terms. These are exactly as they sound. They are terms that have a variable, terms with a variable. So if I use the example that you see up top, 7x plus 3 minus 5x plus 8 plus 4x minus 1, I'm going to identify all the terms that have a variable in them. So if I look at this, I see that 7x is a term with a variable. Negative 5x is a term with a variable. And 4x is a term with a variable. So those are referred to as variable terms. Underneath variable terms, because it directly relates to it, you see a word that I hope you have seen before, which is coefficients. So coefficients are the number next to a variable. Most often, you're going to see that number next to it in the front. So we will only look at our variable terms to determine what our coefficients are because we want to pick the number next to the variable. So in the first variable term, 7x, my coefficient would be 7. In the second term that we listed as a variable term, negative 5x, the coefficient would just be the number next to the variable, so negative 5. And for 4x, the coefficient again is just the number next to the variable, so we would just want to list 4. So now you can see the difference between listing the variable term and what a coefficient is. The coefficient is just the number in front or next to the variable. Now on the other side, branching off from the same expression, we have constant terms. These are terms without a variable. So these are things that are all alone. So I'm going to go ahead and mark everything that doesn't have a variable next to it. That would be plus 3, plus 8, minus 1. And we're going to think of those signs as positives and negatives. So what we really have here is constant terms, which again are terms without a variable, as 3, 8, and negative 1. And you can see that constant is just kind of another word for just plain old numbers. Okay? And just to help with coefficients, I'm going to go back and highlight here where your coefficients are. So you're talking about 7, negative 5, and 4. So you can kind of see the difference between the way I'm color coding the top of where everything is falling. So why don't you try the example? The expression is negative 6 plus 8. I'd like you to try to write down the variable term, the constant term, and the coefficient. So pause the video, see if you can answer those 3 questions, and then resume the video to check your answers. So if I'm looking at negative 6 plus 8, first I want to write down the variable term. Looking above, those would be the terms with a variable. So terms are separated by pluses or minuses. You can see negative 6 plus 8 is actually 2 terms. When you look up at the example we had for parts of an expression, we had 1, 2, 3, 4, 5, 6 terms. So we're specifically identifying the variable term. That would be the term with the variable, which is negative 6x. Branching off of that, then the coefficient is the number next to the variable. So that would just be the negative 6. Make sure to take the sign with it. And then the constant term would be the term without any variable. So that would just be 8. So hopefully you're feeling okay with the parts of the expression vocabulary. Now today we're going to review 2 things from the past that are going to be helpful for us in our upcoming chapters. And you'll see these skills used over and over again. Our first one is the distributive property. So it says to distribute means to give. The number, variable, or term outside a set of parentheses must be multiplied by every term inside the parentheses. So if we're going to distribute or give, we want to make sure we give to everyone. So you might have addition or subtraction inside that parentheses. The process doesn't change. Whatever's on the outside is going to get multiplied by everything on the inside. So A times B would be AB. A times C would be a positive AC. If it was minus, you still do the same thing. Just watch out for your signs. A positive times a positive, A times B would be AB. A times negative C, a positive times a negative would be negative AC. Now, I know it can be a little confusing looking at just the variables, so let's look with some examples. So outside, we have -4. That needs to get distributed through the parentheses. And when we say distribute, remember, we are multiplying. That's really important. So -4 times -w, which is really -1w, would be 4w. -4 times 10 would be -40 or -40. So our answer is 4w minus 40. In the second example, we have 7 times y, which is 7y, and 7 times 4, which is 28, positive 28. So our final expression answer would be 7y plus 28. And in our last one, we're throwing this one in the mix because there's a fraction outside. Does not change anything, and please feel free to use your calculator whenever you need. 1/4 of 8 is the same thing as doing 8 divided by 4. So that would be 2x. 1/4 of 8x would be 2x, and then 1/4 times -4 would be -1. So our answer there would be 2x minus 1. So that's one of the important skills we want to review today is distributive property. Remember, you're giving whatever's on the outside to everything on the inside, and you're using the operation of multiplication. Another very important skill that we're going to end our lesson with today is combining like terms. So again, not new, old skill that we want to make sure we become really great at. So you can simplify an algebraic expression by combining like terms. This means to combine common variable terms and then constant terms, right? So you want to think about what's alike, and those are the only things that you should be combining. So x's get combined with x's, numbers with numbers, q's with q's, xy's with xy's. You want to look for like terms. So if I'm looking at this expression, it says example, simplify the expression below. I want to look and I want to code what is alike. So the first thing I see is 7x. I want to look through the rest of the string of this expression and find all the other x's. So I see -5x and I see positive 4x. And I'm going to take those coefficients and add them up. So 7 minus 5 is 2. Plus 4 is 6. We have 6 x's once we combine all of our variable terms that have x's. Then I see a positive 3 that hasn't been coded. So I'm going to underline that. And I'm going to look and I see I have another number here I can underline and another number here I can underline. Numbers count as like terms. They're all just constants, all plain numbers. So we can combine them. 3 plus 8 would be 11. Take away one more would be 10. So the final simplified answer to that long expression is 6x plus 10. We've taken something that was long and looking more complicated, and because there were like terms, we were able to combine them and get just a shorter, nicer, concise answer. So I'm going to try one more with you, and then you'll do the last example. So in this string, I see 7p. Now, I don't have to use circles and underlines. I could use an underline for 7p and maybe a squiggly for -1 because they're not like terms. So I just want to make sure I use different codes. So 7p, if I decide to underline this time, I would also want to underline -9p. And I see -1 is not like my variable one, so I'm giving it a different symbol coding. I'm squiggling it, and that means I'm going to squiggle underline 5. It doesn't matter what you pick. boxes, triangles, circles, lines, double underlines, squiggly lines. The point is just to take the time and find the things that are alike. So now I know I can combine 7p and negative 9p, or in other words, 7p subtract 9p, which is negative 2p. And I can do a negative 1 and a positive 5, which would be positive 4. Now, I want to talk about this on day 1, and I won't necessarily do this for every problem, but the order of this does not matter. So if you wrote instead 4 minus 2p, that is exactly the same thing as negative 2p plus 4. Doesn't matter. So in the last one, I'd like you to pause the video and try to simplify that on your own, then resume the video when you are ready to go over the answer. All right, now that you had a time to check and try yourself, here's what you should have had. So just to show you it doesn't matter what you use to code, this time I'd use the circles and the squiggle underlines. 5h and 7h should have combined to make 12h. Negative 6 and negative 8 should have combined to make negative 14. Or again, you could write it reverse, negative 14 plus 12h. So at this time, you will complete whatever practice activity was left for you by your teacher. For right now, we're going to move on to closure. So you may be coming back to this video if you need to, based on whatever directions are left by your teacher. We'll complete the closure here to conclude our video lesson. So it says, consider the two expressions shown below. So I give you expression 1 and expression 2. Make sure you look at those very carefully. And then I have 2 questions I'd like you to answer. What do they have in common? And what is different? So at this time, please pause the video, try the best you can to come up with what you think the answer or answers to these questions are, and then resume the video to go over the answers. So for the closure, you are looking at expression 1, which was 5x plus 3 minus 2x minus 1, and then expression 2, which was 5x plus 3 with parentheses around it, minus 2x minus 1 with parentheses around it. So for what do they have in common, I was hoping that you'd see that they have similar terms. We have variable terms, we have constants. All of our variable terms are x's in both of them. And even our coefficients are pretty much the same. Now, in the first expression, we have a variable term of negative 2x. In the second expression, we have a 2x with a negative out front. But that leads me into what is actually different. We have parentheses in the second expression, which is actually going to change how we have to simplify that. So even though expression number 1 and expression number 2 look almost identical, the adding of those parentheses is really going to change our process. And that's exactly what we're going to look at in our very next lesson. So that concludes our lesson on distributive property and combining like terms, day 1.